Hi students, welcome back to our class. How are you all? I hope you all are fine. Students, now I will teach you lesson number 6, Magnetism, subject physics. Students, now I will teach you the definition of temporary magnet. So, temporary magnet, a magnet which soon loses its magnetic properties, is called a temporary magnet. For example, when you keep bar magnet near this iron bar, so this iron bar gets the properties of magnet and it behaves as a temporary magnet. The end near the north pole of the bar magnet, this end gets the south polarity, that is south pole, and this end gets the north polarity, that is north pole. But students, when you remove this magnet from this place, so it loses the properties of magnets and it is just as an iron bar. So in this process is a magnetic induction in which this iron bar becomes a temporary magnet. Similarly, here you will see that this insulated copper wire, the one end is attached to the battery and it's wound around the iron bar. The coils of insulated wire, these are wounds around the iron bar, and this come out this end B and touch to the negative terminal of the battery. So students, when you switch on, so the current will be passed in the insulated copper wire. The current will be passed in this direction and it moves in the coils in the clockwise direction. But when you will see from this end, the current it is coming from this end in the anti-clockwise direction and it moves and touches to the negative terminal of the battery. So the end where the current enters, this end gets the south polarity, and the current which is coming out from this end, it gets the north polarity. So the iron bar, in the presence of current, it behaves as a temporary magnet. But when you switch off, and the current will not pass through this coil, it loses the properties of magnet and it's just become an iron bar. So in this electrical method, we can make an iron bar as a temporary magnet. So lastly, we can say that students, temporary magnet, a magnet which soon loses its magnetic properties, is called a temporary magnet. Now students, I will define the definition of permanent magnet. So students, permanent magnet, a magnet which does not lose its magnetic properties, is called a permanent magnet. For example, by electrical method, you use the steel bar. So this steel bar become a permanent magnet in electrical method. So the current pass through this end A through these coils. These coils are wound around a steel bar. This current is passed through these coils and come out through this end and moves through the negative terminal of the battery. When this switch is on, so the current is passed continuously to these coils and the steel bar, it becomes a permanent magnet. This end A get the south polarity and this end N get the north polarity. So here students, we can make a permanent magnet from a steel bar in electrical method. So lastly we can say that students, permanent magnet, a magnet which does not lose its magnetic properties, is called a permanent magnet. Now students, I will define you electromagnet. An electromagnet is a current carrying coil with a core in it. You can see in the example, this is a current carrying iron core. Here the current is carrying through this insulated copper wire through this coil. Through this coil the current is moving in this direction. So it is coming out and it is touched to the negative terminal of the battery. So current is carrying in this coil having the iron core. So it is called a horseshoe electromagnet and having this north pole and south pole. Here students, it is a bar electromagnet having the iron core inside these coils. Here the current is passing from the positive terminal of the battery in these coils and coming out from the end B and touch to the negative terminal. When we switch on, so current is passed through these coils or through these coils where iron core is inside. So this becomes a magnet and it is called a electromagnet. Students, choice of the material of core of the electromagnet. So students, for the temporary electromagnet, we will use the core inside this coil is of iron, but for the permanent electromagnet, so we will use core of steel. It will be steel core. Then it will become a permanent electromagnet when the current is passing through these coils. Now students, I will teach you strength of the electromagnet. So students, the strength of electromagnet can be increased by increasing the current in the coil. Here we will increase more current in this coil, so the strength of the electromagnet it will increase. Second, by increasing the total number of turns of the coil. Students, here on this core, if you will increase more turns of this copper wire, more turns will be there, so it will be made or it will be increase the strength of electromagnet. Now students, I will teach you making of an electromagnet. and it's removed and it attached to the negative terminal of the cell. So students, when the current is passed through these coils, this screw, it will become a electromagnet. And students, maximum number of the coils will be there. Here this turns, the turns will be maximum. This turns will be maximum. So it will become a strong electromagnet. The attraction property of the electromagnet, it will be very strong and it will attract the more iron piece. Small iron pieces, just example, small iron all pins, and these small iron all pins, this will be attracts. This all small iron pins, this will be attracts here. So students, we can make a electromagnet when the current is passed through these coils and the more turns will be there, so it will become a strong electromagnet. Now students, I will teach you uses of magnet. Students, temporary electromagnets are used in the devices such as electric bell, telephone receiver, loudspeaker, magnetic toys, etc. And students, strong electromagnets are used loading and unloading the scraps of iron. And students, permanent magnets are used in electrical measuring instruments such as galvanometer, ammeter, voltmeter, etc. Students, magnets are used in electrical motors, speakers, computers, etc. And students, magnetic compass are used in finding the geographic direction at a place by sailors or pilots. So these are the uses of a magnet. Now students, I will teach you care and storage of magnets. Students, as you know that a magnet loses the properties of magnet, and a magnet have the tendency to lose the properties of magnets. So therefore, care is taken not to leave the magnet all alone. To store the magnets, magnetic keepers are used. The magnetic keepers are the pieces of soft iron. Here you can see that for the storage of magnet A, magnet B, these are placed having the opposite polarity on one side. On the other side, it is also opposite polarity of the magnet A and magnet B. And between these two magnet A and B, piece of wood is there. We will keep two soft iron pieces. This is the one soft iron pieces, and this is the another soft iron pieces. But due to magnetic induction, the end near the north pole, it gets the south polarity on soft iron piece, and this other end, it's near the south pole of the magnet, it gets the north polarity. Similarly here, this end of the soft iron, it gets the north polarity because of this south pole of the magnet, and this end is the south polarity because of the north pole of the magnet. And similarly, student, horseshoe magnet to storage of horseshoe magnet, only one soft iron piece is needed. But this opposite pole of the soft iron piece get the south polarity due to the north pole of the horseshoe magnet, and this end of the iron piece get the north polarity due to the south pole of the horseshoe magnet. But students, horseshoe magnet keeps or needs only one soft iron piece for the storage of horseshoe magnet. Now students, I will teach you demagnetization of a magnet. So students, magnet can be demagnetized. That is, the magnetic properties of a magnet can be destroyed by the following ways. First, by rough handling. Second, by hammering the magnet repeatedly. Third, by heating the magnet to a high temperature. Fourth, by passing the alternate current through the coil around the magnet kept in east-west direction, and fifth, by dropping the magnet repeatedly on a hard surface. So students, I hope you understood the concepts of this lesson. Thank you